you're cooking?
Fire.
A fire starting on your stove.
The one way that can happen if you have the oven or whatever.
Yes. So, did you guys know that there are different ways to stop fire? You cannot stop all the fires with one way.
Yeah.
I believe with the oil fire, there's different classes. I think it's class A, class B, class C, class E. I am not quite sure.
Firefighter?
No, I'm not a firefighter, but I did learn it, but I just don't remember which one is which. I think with an oil fire, like a kitchen fire, you cannot throw water on it. It's just going to increase it. So it's best that we know the different kinds of fire to know how to avoid it, how to stop it from spreading, okay? Because the last thing we need is we're panicking, oh my God, and we throw something that is not supposed to be thrown and it causes more of a reaction, right? So you want to make sure you're doing everything as safe as you can. Go ahead, Samira.
I saw a fire once. You know, I saw a fire once in my house, so if my mom was cooking, and then underneath the where you cook underneath the oven, the fire came up, and then my mom was screaming, then we all came out, then my dad came out, he got the fire extinguishers.
Fire extinguishers are the best option
and
for
then
any.
He did it, and then now the food was rolling in my again.
Nice. Go ahead, Tyson.
So you know last year we about to have a science fair for him. You know what I was just thinking of? That you could did if you did have it, maybe if it still allows us to on a firework, rocket, see if one of those fire in the air.
Ooh.
See, that would be cool, but maybe next year. Okay. So when those are your chemical properties, ability to rust because it changes using the oxygen, water, and the iron, and the flammability, right? Because you won't be able to get that substance back. Okay, like the paper. If you burn paper, right? Are you able to put the pieces of paper back? No, it's all ash. You wouldn't even be able to tell that it is a piece of paper. Okay. Now,
burnt ashes.
Ashes. What is it?
Burnt ashes.
Those are burnt ashes, and it could be from anything. It could be from anything.
It could be for your it could be for your skin, right?
No. Well, you would be able to tell because you would have pieces of. Why are we asking about that? Yes, the periodic table of elements. So how can we identify matter using physical properties? Okay, so physical properties are useful for describing types of matters, but they are also useful for identifying unknown substances. Okay, now on page 392 at the top, we see 4 different types of substances. We see table salt, sugar, baking soda, and an unknown substance. They're all white, but their masses are different. The melting point is different and their density is different. If I were to put in front of you, if I were to put in front of you sugar and salt, and I told you, put this, and I don't tell you which one is the sugar or the salt, and I tell you, put salt on your fries.
Okay.
Will you be able to tell which one? Okay. No, but what would you do first to find out which one is the salt?
Taste test.
Taste test. You taste test it, right?
You know the difference between salt and sugar?
What?
They both, salt and sugar, they both look the same, but salt is smaller.
Smaller, but if I put it all together and you can't tell the difference, and I tell you here, put sugar in your lemonade.
Right, you say you put all of it together in the same bowl?
No, you can't. I wouldn't be able to separate that. But if I give you 2 containers, one of them is salt, one of them is sugar. Yeah, you might put salt in your lemonade because you wouldn't be able to tell since they both have similar physical characteristics, right? But now, how can you tell? Once again, what's the mass for salt?
14.5.
14.5. And the sugar, for sugar?
11.5.
Which one is heavier?
Salt.
The melting point in Celsius?
801.
801. And sugar?
148.
148. So it takes a longer time to melt table salt than sugar. And the density,
2.17 or 1.53.
2.17 for table salt and sugar 1.53. Okay,
I got a question.
go ahead.
Baking soda in the unknown got 16.0.
Ah,
And then you got salt in the unknown 801. And then you got salt in unknown 2.17 again.
so salt and unknown, if I just look at the mass, how could I tell the difference between salt and unknown substance? Look, by just looking at the mass. The salt is doesn't have as much mass.
No.
Which one has more mass?
So,
Unknown.
The unknown, right? So, however, look at paragraph number 2 on page 392. You cannot identify the unknown substance by its color. All of the substances are white, but you cannot also identify the substance by its mass or its volume. So, mass and volume are property of matter that change with the amount of the sample present. However, the melting point and the density are properties of matter that do not depend on the size or the amount of sample. Okay, so if the mass and the volume are the same, you can always try using the melting point. Which one melts faster? Which one has a hard time melting? Okay, so when you identify matter using physical properties, you have to consider baking soda, maybe. You have to consider the properties, how the properties are alike, and how are they different? Okay. Alrighty. Once again, you have physical properties, which are your mass, volume, density, weight. What is the difference between mass and weight? Which one changes, mass or weight? Weight changes because weight is based on the gravitational pull from the earth. Here on earth, we have a weight, right? Because of the gravitational pull. But if we were to go to the moon, our weight would not be the same as on earth. However, our mass would stay the same because there's not as much gravitational pull on the moon. Okay. And then you have your chemical properties, which are flammability and ability to rust. Flammability. Yes, Horace? Eric is blocking himself. Why? How is he blocking himself? With his those are movies.
I'm done.